Thank you for watching this video. In this video, I'm going to share a little bit about what we're going to learn in digital logic. So first of all, in the digital logic, maybe we can see a basic one on the signal. Signals, maybe we start with electrical signal, which is electric signals is represented as a change in voltage over time. So the change occurs when the voltage begins at 0 and increases until it peaks. The signal then drops back down its lowest level. So how about in computer network? How about the signals in computer network? So we can see that in computer network we send information from one computer to another. This information may be in form of data, voices, pictures, videos, and etc. In order to transmit this information across the network, it needs to be in electromagnetic signals. Therefore, in a computer network, information flows from one system to another in terms of signals via transmission medium. So we need transmission medium to transmit our data. So the signals is in analogs and also digital. So that's why we're going to look differentiation between these two. First we're going to look on the analog, and then we're going to look into digital. So the first thing that maybe we can see is on the wave of signals. This is a signal for analog, and this one is the signal represented for digital. And this picture is a combination signals between digital and analog. You can see the blue color represent as the digital signals, and the green one is represent as analog signals. I can see that there is two different signals over here, and we can easily differentiate them. And there is a big keywords that you can differentiate between these two. First keywords for the analog is continuous, and the keywords for digital that you can memorize is discrete. So now we have the keywords that, but we maybe have another key to differentiate between these two, which is on the waveform. The waveform for analog is on the sine, while for digital the waveform is in the square wave. So now over here you can see that you can see the difference between signal, digital, and analog, and you have the keyword. Analog is continuous, digital is discrete, and the waveform is sine for analog and square wave for digital. It's easy to memorize, isn't it? So now maybe we can have to move for the example devices that are available in analog. So over here we have the first examples, which is of course our clock. This is the analog clock, and then we have the headphone as the analog devices. And the third examples is, yes, of course, speaker. It's also analog. And then this one is thermometer, but there is two type of thermometer. This one is the analog versions of thermometer. And your microphone is the analog device. And last examples is multimeter. So multimeter, there is also two types, which is analog and digital. Over here, let's see the example devices for digital. This is the clock, digital clock, of course. And then the multimeter, this one is the digital type. And you have this one I really love, which is Nintendo Switch, the game. And you have also many other devices like your laptop, your computer, and also last examples it will be your daily devices that you see currently, which is thermometer. This one is digital thermometer. So I can see over here we can conclude a little bit the example of analog, the example of digital devices, the key which is continuous, the key for digital is discrete, and etc. Now we need to jump to analog signals. Over here we can say that analog signals is a continuous wave form that changes smoothly over time. So analog signals can have infinite numbers of values and varies continuously with time, and the examples of analog signals is like human voice. When we can speak, we use it to transmit an analog signal. And another example is electrical signal from an audio tape can also be in analog form. So there is this picture which is represented as the basic characteristic of analog signals. We can see over here there is amplitude, time. If we have time, we can have frequency, and also over here we have the phase. So after this, we're going to look deeper a little bit on the basics characteristics of analog signal. So there is four. First, it is on amplitude. Amplitude is the signal represents or refer to the height of the signals. It is equal to the vertical distance from the given point on the waveform of the horizontal axis, and the units that measures for the amplitude is volts, ampere, or watt, depending on type of signals. And second is period. Period refers to the amount of time in which a signal completes one cycle. And it can be measured using a period which is on milliseconds, microseconds, nanoseconds, and also picosecond. But normally it's use seconds as the unit measurement for periods. The third one is on the frequency. Frequency refers to the number of wave patterns completed in a given period of time. So to be more precise, frequency refers to the number of periods in 1 second or number of cycles in 1 per second. So normally it's measured in hertz, but it can also be measured in kilohertz, megahertz, gigahertz, terahertz, and so on. And the fourth one we have is phase. Phase is described the position of waveform related to the time zero. So we can see that the amount which the waveform shift forwards or backward along the time axis, it can be measured in degrees or radians. So that's 4 is on the characteristic of analog. So now we're going to look into the advantages of the analog signals. First, the base should for the transmissions of audio and video. Second, consume less bandwidth than digital signals to carry the same information. Third is analog systems are readily placed around the world, and fourth, analog systems are less susceptible to noise. So this is the advantages of analog. Now maybe we can move to digital signals. Digital signals is basically a signals in discrete form. it can have only limited numbers of defined values, just as 1 and 0. And the examples is signal generated by computer or other devices. Digital devices are digital in nature. And there is also the characteristic of digital signals. Of course, this is examples. On this picture we can see there is an amplitude, but the main point is on the bit rate and also bit intervals. What is the bit rate and what is the bit intervals? So the first one, maybe we can see on the bit interval. So there is two basic characteristics of digital signals. Bit intervals is the time required to send one single bit. And for a bit rate is referred to the number of bit intervals in 1 second. So we can see the difference between bit intervals and bit rate. And the bit rate also is the number of bits sent in 1 second, and it's always expressed by bit per second, bps, or other units can be also used, which is kilobits, microbits, gigabit, and etc. And there is the advantages on digital signals, which is first, it is best suited to transmit or transmissions on the digital data. Second, digital data can be easily compressed. Third, digital information can be encrypted. And last advantages is it provides better clarity, because all signals must be either 1 or 0s. But if you can see here, we can have a lot of example differentiation between analog and also digital. So over here I draw the tables differentiations between analog and digital signal. If you look here, there is 10 examples differentiations between these two signals, but we can list many others also. First is an analog signals. We can see that analog signal is continuous signals, digital is discrete signal. Analog signals is used continuously to represent for the informations, while digital signals use discrete values. Analog signal can be affected by the noise during the transmissions, while digital signal cannot be affected by the noise during the transmission. The accuracy for the analog signals is affected by the noise, while for digital noise, which is, it can be said noise immune, because it less affected. Device for analogs is less flexible, while for digital is very flexible. Analog signal consume less bandwidth, but digital require more bandwidth. And for analogs, it can be stored in the form of continuous waveform, while for digital is only on the binary form, which is 0 and 1. Analog is low cost, high cost for digital. Signals are portable for analog and not portable for digital. And lastly, analog signal give observation error but not for digital signals. So now you can see there is a difference between analog and digital signals clearly. I hope that you can see the differentiation between analog signals and also digital signals. So this is the overview what we already learned in this video. So I hope that you have the basic understanding on these two signals, and hope we can see again in another classes and also another video. Thank you for watching this video.